Today we're going to talk about estimating square roots. That's a lot different than when we were trying to find the root of a perfect square. Before we get too far into this, there's some vocabulary that we need to write down in your journals. First of all, integers. You've probably heard of this before. Those are our positive and negative whole numbers. For instance, -3 or -20 or positive 257 and so on. These are numbers that we use in our math class every day. The natural numbers are the counting numbers that you started with in kindergarten. So 1, 2, 3, 4, 5, and so on. Those are the natural numbers. A rational number, this is probably a new term for you today. A rational number is any number that can be turned into a fraction. So that's going to include whole numbers because we can put them over 1. It's going to include decimals like 0.25 that we can change into the fraction 1/4. And it's really going to include any terminating decimals. Terminating means a decimal that ends. So for instance, like our 0.25, that's a terminating decimal because it doesn't go any further. An irrational number is a number that cannot be turned into a fraction. So that's going to include our non-repeating, non-terminating decimals. Non-repeating means there's no pattern in my decimal places, and non-terminating means a decimal that goes on forever and ever and ever. It needs to meet both requirements before I can say it's an irrational number. I have a Venn diagram to help you understand how the numbers fit together. I have the smallest set of natural numbers. Remember, those are counting numbers. My next largest set is integers. Integers are our positive and negative whole numbers. Natural numbers are part of that integer set. But there are integers, especially our negative ones, that are not part of the natural numbers set. Our natural numbers and our integers are both part of the rational number set. The natural number 2, for instance, can be considered a natural number, an integer, and a rational number. The only thing it can't be considered is an irrational number. That's a completely different set. Remember, for our non-repeating, non-terminating decimals. They are all part of a set called real numbers. Numbers that exist in nature. The opposite of a real number is an imaginary number. And we'll talk about that probably later on in the year. We're going to classify numbers, first of all, with as many of the following as possible. I want to know what or which ones of these 4 sets these numbers fall into. We're going to start with the number 2. Number 2 is one of the counting numbers you learn in kindergarten, so that's a natural number. I can turn it into a fraction by putting it over 1, so it's also considered rational. It's one of my positive and negative whole numbers, so it's also an integer. The only one that it can't be is an irrational number. They can't be rational and irrational at the same time. Next, we're going to go on to 1.22222 on forever. We can also write this as 1.2 with a line over the 2 to show that it repeats. It's not a natural number. This is definitely not a number that you learned in kindergarten. It's also not an integer because it's not a positive or negative whole number. It is, though, a rational number. Remember, rational numbers include repeating decimals. Later on in this unit, we'll show you how to change those repeating decimals into fractions. The next number is a big, long, never-ending decimal. Look at the decimal places. Do you see a pattern? Does it repeat? Well, if the answer is no, it's a non-repeating, non-terminating decimal. It doesn't repeat and it doesn't end. So that's an example of an irrational number. The fraction 4/7 is already a fraction, so we know that it's a rational number. It's not a natural counting number, and it's not a positive or negative whole number, so rational is the only set that it fits. How about negative 8.4? Is it natural? Is it an integer? Is it rational? Yes. Decimals that terminate or end are rational numbers. We'll learn how to change those to fractions. And finally, square root of 2. If you put square root of 2 into your calculator, you get the decimal 1.414213,562. Those are only the decimal places that my calculator can handle. This is a never-ending decimal. There's no pattern in the repetition. So since it's non-repeating, non-terminating, this is irrational. If it's irrational, it doesn't fit into any other set. We're going to move on to estimating square roots. In order to estimate where a square root lies, we need to know where those roots are in relation to the number line. So I want to estimate the square root of 20 today. First, I'm going to say that the square root of 20 has to be in between the square root of 16 and the square root of 25. So I know that it's going to fall somewhere in this range. So that's going to tell us that it's greater than 4 but less than 5. We're going to zoom in just on that part of the number line. I've marked some important parts here on the number line in order to help me out. I've marked the halfway mark between 4 and 5 at 4.5. I've also marked the halfway mark between 4 and 4.5. That's 4.25. These are just decimals that are going to help me out when I'm estimating square roots. The halfway mark between 4.5 and 5 is 4.75, or 4 3/4. In order to estimate square roots, we have to know how to find the halfway mark between two numbers. That's called finding their average. So I'm going to find the average of 16 and 25 to find out what number sits at this halfway mark. In order to do that, I add the two numbers together. 16 plus 25 equals 41. Then I'm going to divide that number in half, or divide by 2. That's going to give me 20.5. That means that the square root of 20.5 is here at my halfway mark at 4.5. Now square root of 20 is really close to 20.5. So I know that my square root of 20 is going to be really close to that. Not exactly, but really close. So if I'm rounding to the nearest tenth, 4.5 is close enough. That would be my estimation. Now if I want to get closer, say to the nearest hundredth, then it wouldn't quite be that. It would probably be closer to 4.45 or maybe even up to 4.48. It would be somewhere in that range. Since we're only estimating to the nearest tenth, 4.5 is close enough, and that's where we're going to leave it. My next estimation is going to be square root of 45. We know that 45 falls in between 36 and 49. I've marked some important intervals on my number line: 6 1/4, 6 1/2, and 6 3/4 to help me estimate my square root. To find out where 45 is going to fall on my number line, I'm going to take the average of 36 and 49. 36 plus 49 gives me 85. Then I'm going to divide that by 2 to find my halfway mark. My halfway mark is going to be the square root of 42.5. Square root of 42.5 is very close to 6 1/2 or 6.5. 45 is between 42 1/2 and 49. So I'm going to take another average. I'm going to take 42.5, add it to 49. 42.5 plus 49 gives me 91.5. When I divide that by 2, I get 45.75. So 6 3/4, the halfway mark, is going to be the square root of 45.75. My square root of 45 is really close to that, just a little less. So I know that it's going to be somewhere between 6.7 and 6.75. If I'm estimating to the nearest tenth, I'm going to say that that's really close to 6.7. It's closer to 6.7 than it is to 6.8. If I'm estimating to the nearest hundredth, I'm going to say something in between. Maybe like 6.73. But since we're only estimating to the nearest tenth, I'm going to leave it as 6.7. If I were rounding this to the nearest whole number, it's much closer to 7 than it is to 6. So if I were rounding to the nearest whole number, I would have said 7. Some last minute things to remember. We are talking about perfect squares in this unit, and any square root that we're going to be asked for, they're going to be asking you for the positive root. If they ask you to find a square root, simply list the positive number. However, If they're going to put a negative out in front of the square root sign, otherwise known as a radical, then they're asking you for the negative root. So negative square root of 81 would be negative 9. Square root of 196 without the negative out front is positive 14. And negative square root of 225 is negative 15. They're going to tell you which one of the roots they want. And finally, in an order of operations problem, the square root falls on the same level as exponents. What's under the square root sign or a radical is considered to be in parentheses, so that would be done first. So if I were to solve this problem, I would multiply the 4 times the 36 and get 144. Then I would take the square root of 144 and get 12. And finally do the addition, and my answer would be 14. If we're going to start doing video lessons, it's important to remember to write down your questions when you find them so that you can ask them in class the next day. Our assignment today is in your journal, pages 128 and 128B. There's a page in between those that you're going to skip. Good luck.